Very good morning, class. So today we're looking at Euclidean geometry. Oops. So we're doing exercise 4, and today we're looking at numbers 4 and 5. And exercise 4, which is on page 263. Okay, so here we are told that PB is a tangent to circle ABC. So if PB is a tangent, what can we conclude from there? That B1, B1 is equal to angle C. Stand theorem, not so. Then we are told, we are asked to prove that triangle PAB is similar to triangle ABC. Okay. So to prove similarity, I want to prove two things. It's either the two triangles are equiangular or the sides are in proportion. Okay, so this of course let it be where it's equiangular. So firstly we know that B1 is equal to angle C. The angle theorem. See another angle? Angle A1 is equal to angle B2Y. Alternate angle. So that's enough to prove similarity there, not so. So let's go. We say A in triangle PAB and triangle ABC. So PAB, which is this angle here, is equal to angle. So A1 is equal to B2. We said it's going to be alternate angles with PA being parallel to BC. And then B1, angle B1 is equal to angle C. Why? It's a tan theorem, not so. So therefore angle P has to be equal to angle A2. Why? The third angle in triangle. That of course is enough to conclude similarity. So therefore triangle PAB is similar to triangle ABC, which is angle. Right, you guys understand? Any confusion here? No? Then in B, we said what's going to follow? A similarity question, a ratio question. So we can start by saying PA over AB is equal to AB over BC, which is equal to PB over AC. Why? Because triangle PAB is similar to triangle ABC. So let's see what they want. They want it in ratio form, not so. So they want PA is to AB as AB is to BC. That's the one they want. Not so. So I can just conclude therefore PA is to AB as AB is to BC. Okay. Any confusion there? C. AP. So again the ratio. So AP over AB is equal to AB over BC equals PB over AC. Why? Because triangle PAB is similar to triangle ABC. Right, so what do they want? They want AP, BP, AB. Now you see there's two ABs. So let's see what is the other one? AC. So that is the AB they're referring to. You see how I chose that one now? Because once I choose that, then I got one there and don't need that one. Once I have that numerator, I don't need that denominator. Okay. So, but is it in that form? No. Must interchange those two. Not so. So therefore, AP over PB is equal to AB over AC. Any confusion there? The last one of this exercise. Number 5. So this gets sweeter and sweeter, no? Can't help but to fall in love with the sums. Huh? No? Then you're not doing enough of it. People, we are told that AB is the diameter of the circle. People, if AB is the diameter, what do we know? C2 is 90. Why? Angle in semicircle. Then we are told that, okay, so this is your diameter, okay? DC is the tangent. This BD, DC is the tangent. This is the tangent, what do we know? C1 is equal to angle A. And C3, of course, is B1. Not so. Then we are told that BD is perpendicular to CD. So what do we know now? C2 and CD is both perpendicular. So what do we know at this point already? B2 has to be equal to B1. Why? Third angle in a triangle. And the first question, prove that BDC is similar to triangle BCA. It's like a given. Okay, I'm looking for something challenging, man. No? You're asking yourselves, challenge me, man. No? Alright, so let's go. In triangle BDC and triangle BCA. What did we say? What can we do? We say that C1 is equal to angle A. Why? Tan chord theorem. Then we say that C2 is equal to 90 degrees. Why? Angle in semicircle. Angle D is 90. Why? Given. You see, it's not on the diagram, so I must state it. Given that BD is perpendicular to C. So therefore, C2 is equal to angle D. In the third case, the third angle, we can say that B1 is equal to B2. Why? The third angle in. Is that enough to conclude similarity? Yes. So therefore, triangle BDC is similar to triangle BCA. Why? Angle, angle, angle. Okay. Instead of asking you to prove this here, they could have told you, prove that angle B1 is equal to angle B2. Then you have to know you must use similarity. Or they would ask you to prove that BC by 6 angle B. Or BC by 6 angle ABD. Same. Let's prove similarity first. Okay. Well, let's look at B. B says if AB is 25. AB is 25. And AC is 24. Now, without going any further, what can be calculated? BCY? Not so. Calculate. BC. Come on. Alright, but what do we say? What always follows this? The distance question. Okay, so if I would have written out the ratio here first, and then realize afterwards that BC must be calculated first, and then probably to calculate CD, I would need to use the ratio anyway. Can you see that, people? They wouldn't have gone to waste. So let's go. We would have said that BC squared is equal to 25 squared minus 24 squared. Why? Pythagoras. With angle C2 equals 90 degrees. Okay. So that's BC squared is equal to, I think it's 49 if I'm not mistaken. 25 squared minus 24 squared. 49. The square root thereof is, of course, 7. 7 centimeters. Okay. Now they ask you with regards to CD, which is this length here. So of course I'm going to use the ratios, not so. So what do I say? I say BD over BC is equal to DC over CA equals BC over BA. Why? Because triangle BDC is similar to triangle BCA. Now we have lengths, now not so. Right, what do we want to calculate? We want to calculate CD. Is there a CD? Yes, there's a CD. So I must use this ratio here. Okay, so let's put in what we have. BD is what? We don't have BD. Over BC. 7. Not so. Equals DC. So what we're calculating, DC over CA, 24. Equals BC, 7 over BA. What do we notice? What are we going to use? Those two. Why not these two? 200. Why not these two? We're not calculating. We don't need BD. That's not a question. Guys understand? So these are the two ratios I will be using. So what do? Cross multiply. Not so. So that will be 25 DC is equal to 7 by 24. Not so. So divide by 25 both sides. So DC works out to be, work it out, people. 6,7. 6,72 centimeters. People, is there any confusion? No. Okay. So that brings us to the end of exercise 4. So now we're going to look at the next example. Okay.